Hello everyone, and welcome to another video in my channel. In this video, we are required to find the square root of I. In case we don't know, I is an imaginary number, and then I is equal to the square root of minus 1. If I square both sides, I squared equals to minus 1. Let us do well to remember this point because we are going to need it later on in the video. For me to find the square root of I need to equate I to a complex number, which is a plus bi, where a and b are equal in values or in sizes or in magnitude. Now, what will I do to remove this square root sign? I need to square both sides. If I square both sides, I have I square root of I all raised to power 2 is equal to a plus bi all raised to power 2. Now this and this will cancel out, giving us I. Then if I expand this bracket, I have a squared plus 2abi, then plus b squared I squared. Let's remember that I squared is minus 1. So I'll put minus 1 in place of I squared here. So it becomes I is equal to a squared plus 2abi minus b squared. And so I have a squared minus b squared plus 2abi equals to I. Now, to properly make the term in the left hand side equal to the term in the right hand side, I have to convert this to a complex number such that I will have a real part and an imaginary part, just as we have a real part here and imaginary part. So to make it to have this form, I have 0 plus I equals to a squared minus b squared, then plus 2abi. So this real part is a squared minus b squared equals to 0. I will make this equation 1. And the imaginary part is 2abi equals to I. Let's make this equation 2. Now to solve 1 and 2 simultaneously, I'm going to make a the subject of equation 2 and then use substitution method. So a equals to I over 2bi if I divide both sides by 2bi. Now this and this will cancel out, giving us 1 over 2b. So a is 1 over 2b. Let's call this equation 3. We will now substitute 1 over 2b for a in equation 1. So I have 1 over 2b all squared, that is equation 1, which is this, minus b squared is equal to 0. Now opening this bracket, I have 1 squared, which is 1, all over 2 squared is 2 times 2, which is 4. Then b squared, we have it as that, minus b squared equals to 0. The LCM is 4b squared. Now 4b squared divided by 4b squared will give us 1. 1 times 1 is 1. And 4b squared divided by b squared will give us 4b raised to power 4. That is 4b squared times b squared, which is raised to power 4 here. According to this law of indices, if I have a raised to power b times a raised to power c, it can be written as a raised to power b plus c. So I'm merely adding the powers together since the bases are the same. The same thing was applied in this case. So it equals to 0. And so 1 minus 4b raised to power 4 is equal to 4b squared times 0 when I multiply both sides by 4b squared. Then I have 1 minus 4b raised to power 4 equals to 0. I can convert it to difference of two squares. So I have 1 squared minus 2 squared b squared raised to power 2 is equal to 0. Let me go up here and then continue. So what I have earlier on is 1 squared minus 2 squared b squared raised to power 2 is equal to 0. So I now have 1 minus 2b squared, then 1 plus 2b squared equals to 0. Now let us equate each bracket to 0. So it becomes 1 minus 2b squared equals to 0 first, and then 2b squared equals to 1. And if that's the case, b squared equals to 1 over 2, or b equals to plus or minus 1 over root 2 when we square root both sides. Let us also remember that in this part, 1 plus 2b squared equals to 0, and so 2b squared equals to minus 1, or b squared equals to minus 1 over 2, and then b is equal to plus or minus 1 over the square root of minus 2, which is the same thing as plus or minus 1 over the square root of 2i. Good. Now let's recall that a is equal to 1 over 2b. So let us find the value of a given that b is plus or minus 1 over root 2. So a equals to 1 over the plus or minus 2 times the square root of 2. Good. Which is equal to plus or minus 1 over, now 2 can be written as root 2 times root 2, then times 1 over root 2. This should be 1 over root 2 here, please. 1 over root 2 here. Good. Then this and this will cancel out, and I have a equals to plus or minus 1 over root 2. Now, let us recall that our square root of I is a plus bi. Now, this part is the imaginary part of this complex number, and so root I equals to a being plus or minus 1 over root 2, then plus or minus b being this part now, which is 1 over root 2i. So I have root I equals to plus or minus 1 over root 2 and plus or minus 1 over root 2i. Please like this video if you find it interesting, subscribe to my channel if I haven't done so, and also share this video. Thanks for watching, and see you in another video. Bye for now.